All right, we've got our final section on surface area here. This time we're dealing with the sphere, the wonderful sphere. Have no sphere. We're going to find the surface area of the sphere. Okay, I'll stop. All right, our first important thing to write down here would be our surface area of a sphere formula. And this is the total surface area. Sometimes we just put a T there, sometimes we put TSA, total surface area. But in any event, it is 4 pi r squared. Our radius being the radius of that, what they refer to as the great circle of the sphere, all right? The biggest circle disk you could cut out of that sphere. That's the radius that we're talking about right here. All right, next we have a hemisphere. So half a sphere. Half a sphere. So if a full sphere is 4 pi r squared, what would a hemisphere be? Well, logically, we would just cut it in half. But what happens when you cut it in half? We get this whole circular face happening down there, right? So with a hemisphere, it is indeed half the sphere in 2 pi r squared, right? Half of 4 is 2. But we also have the addition of that circular face we just created when we cut this thing in half. So we end up with is 3 pi r squared. So if we say find the surface area of the hemisphere, we are telling you that it does have that base, and this is the formula you should use. All right. It includes the base when we're talking about a hemisphere. If it's in the context of an application problem, say, for example, we do some kind of a composite figure and we have like a grain silo or something, right? So we have this sitting on top of a cylinder. Okay. Well, now we'd only be using this portion when we're talking about the hemisphere because that circle base, this part right here, is inside the figure. Okay. So it's super important. But if you're just saying hemisphere, this is the one we're going to want to use. Okay. Cool. All right, so we're gonna start with a more basic problem here. Always good to start out a little bit easy. That way we don't pull the math muscle. We don't want to do that. So we'll ease into the math here. Find the surface area of the sphere with a radius of 5 centimeters. Well, since my total surface area of a sphere is 4 pi r squared, and I'm given the radius, whoo, bingo bango, we got ourselves a wonderful problem here. We got all the information we need. That's 25 times 4. That's 100 pi centimeters squared. Beautiful. That's it. Fantastic. I'm sure the rest of them will be just this straightforward, as is tradition in honors geometry. That's sarcasm, children. All right. Find the surface area of a hemisphere if the diameter of the sphere is 6 inches. So the diameter of the sphere is 6 inches, the same thing as the diameter of the hemisphere. Okay. Which what we want to grab from this is that the radius would be 3 inches, right? And as we just talked about, well, why would half the surface area of a sphere not exactly work here? Well, remember, when we cut it in half, we get that circular base. So we know that a hemisphere is going to be 3 pi r squared. Half of the sphere, which is 2 pi r squared, plus the circle base, 3 pi r squared. Let's pop that radius in. 3 times pi times 3 squared, which is 9 times 3 is 27 pi inches squared. Wonderful. Woo! Woo! Good stuff. All right, so we want to find the surface area of a hemisphere if the surface area of a sphere is 64 pi square meters. Now, there's a couple ways of going about this one. I'd like to explore both of those options because math is just so darn exciting that sometimes there's a couple ways to do it. So my first one is let's think about what our formula for a hemisphere is. It's 3 pi r squared. So I need my radius to plug that into the formula, right? Well, if I know the formula for the surface area of a sphere is 4 pi r squared, and I know my surface area is 64 pi, perhaps I could just solve for my radius. Cancel the pi's, divide by 4. Well, what's 64 divided by 4? That would be r squared is equal to 16 square root. I get r equals 4. Yes, I get plus or minus 4 when I solve, but because my radius can't be negative, I'm just going to accept the positive answer. So now what I have is my hemisphere formula. I can do 3 pi times my radius of 4 squared. Cool. So I got 16 times 3, which is 48 pi meters squared. And boom, there's my answer. Now, perhaps you guys are looking at this, you're like, dude, I think I see a better way of doing this problem. And I'm going to go over that right now with you. So let's say we've got, let's see here. So 64 pi, right? That's the full sphere. And I want to know what the hemisphere is, right? Maybe I could set up a proportion, perhaps, or something like that. So let's see here. A hemisphere is 3 pi r squared over, and then my sphere is 4 pi r squared. I want to know my hemisphere and I know my sphere. So I'm comparing here. And what ends up happening is we'll see these cancel out. And really, my hemisphere is 3/4 the size. So when I cross multiply and solve and all that, I will end up with x equals 48 pi. I've seen some people where they multiply or divide by 4 and then multiply by 3. It's the same kind of mathematical approach, but either way, you're going to get the 48 pi meters squared. So if you notice that it is going to be 3/4 the size, which is what we have right here, excellent. You could totally use that in this particular situation. But if I needed to know a little bit more, I needed the radius because maybe there was a cylinder associated with this or a cone of some kind that was in the context of the problem, then you might need to actually be able to solve for the radius. All right, here we have the radius of a sphere is doubled. What is the effect on its surface area? Well, intuitively, we think, well, you double it, right? But we may have noticed in 11, chapter 11, I want to say 11.7, with ratios of areas, that's not necessarily the case. So let's see here. If I take 4 pi r squared, that's my surface area, total surface area of a sphere. And it says we want to double the radius. So if I double the radius, it's going to end up being 4 pi, and then my radius is 2r squared, right? This is doubling my radius. Well, when I do that, I end up with 4 pi, and then 2 squared is 4r squared. All this is multiplication here. And I end up with 16 pi r squared. Over here, it's just 4 pi r squared. So what's the effect? Well, it's 4 times as large or big. How about 4 times the surface area? That sounds a little bit more mathematically correct. Awesome. Well, we could also, just check this out with actual numbers. Let's just say for fun, because math is fun, that my original radius is 3. Okay. That would mean that my surface area, 4 pi 3 squared, is going to be 9 times 4. That's 36 pi. Now, if I were to double my radius, I'd have a radius of 6. So then I'd have 4 pi 6 squared. Now 36 times 4 is, well, it's 144 pi. Yeah. So 36 times 4 would give me 144. There we go. It's 4 times as large when I double it. If I triple it, it's going to be 9 times as large. Okay. And if I quadruple it, it's going to be 16 times as large. Whatever my multiplier is, I am squaring it when we're talking area. Okay. Whatever my multiplier is, I'm squaring it when we're talking area. In volume, it's cubing it. Alrighty, last problem here. Which is greater surface area? A sphere with a diameter of 4 or a cube with an edge of 4? Make your predictions now, folks, because this is very, very exciting here as to what's about to unfold. Actually, we're just going to do a couple of math problems here. So my surface area of a sphere, total surface area of a sphere, we know is 4 pi r squared. So let's just get that one done. If our diameter is 4, what's our radius? Our radius is 2. So I'll pop a 2 in there. And I end up with 4 times 4 now, because 2 squared is 4. That's 16 pi. So that's my surface area here. All right. We might need to do a decimal approximation with that one. Perhaps we do that right now. I've got my TA84 handy, so I can just pop the pi in there, right? You got to stay strapped. You know what I'm saying? So I've got 50.27. Okay. Units squared. Units squared. Cool. All righty. Let's do the cube now. I'm going to switch colors. So a cube, remember, is, if it's a cube, it's a bunch of squares, right? It's made up of all square faces. And the edge is 4. So all the squares are 4. Well, how many squares are there in a cube? Well, I got to think about what I cannot see in this particular drawing, because I can't see through shapes, right? I don't have X-ray vision. So I've got 6 of them if I count them up when I draw it. So one side is going to be 16, right? One face. And there's 6 of those. So 6 times 16. What do we get there? I think that's is it 96, perhaps? I believe. Yay, 96. Just had to double check it. All right. Well, this is clearly larger than that one. So, greater surface area, cube. Awesome. Lovely. Fantastic. Thank you guys for tuning in to this exciting video here for surface area of spheres. I hope you enjoyed it as much as I did. Jenny also, nope, she's just passed out on the floor. She fell asleep in math class. Oh, well. You guys have a wonderful day. America, freedom, rock and roll, and Costco, and River Dog Jenny. No exclamation point. Oh, man, I almost put an exclamation point. All right, whatever. Got to erase that. There we go. All right, have a good one.